We are now recording.
Hi, everybody. Welcome to Securing Your Network with Ansible. I'm Adam Vincent, as the slide says. This is partly introductory and partly not currently working on my terrible internet here, so we're going to kind of bounce back and forth and chop a little bit of stuff and, yeah, bounce back and forth. Overall, what I actually do is data science, and this is more hacking on data than servers, but I still enjoy hacking on it. I'm an automator, which is why I'm talking to you about Ansible. My GitHub account is up there, so is my Twitter handle, which I very rarely use. If you want to talk to me, get a hold of me on email, automatedempire@protonmail.com. That is my BGP key. If you're interested in BGP, come talk to me tonight. We're going to have a BGP key sign for you. So what is Ansible? According to their site, it is a simple IT automation. And really what it is, it's a language for describing computer states. You're trying to, instead of go through all these manual commands of making sure this is set up and that is set up, you're describing how you want the computer to be set up without having to actually run those individual pieces yourself. Ansible operates on a principle called idempotence, and for the math geeks, it is applying a function to itself, giving the exact same result. So when you run these playbooks with Ansible, every single time you run them, you're going to get the same results. You're not going to reinstall the server, you're not going to reinstall this that's already on the server. You're getting exactly the state that you want without a lot of the extra headache. Ansible connects through a ton of different possibilities. SSH is its default, so if you're talking to any of these standard like Unix, Linux types, BSD, you'll use SSH. But there's also a WinRM you can use for Windows hosts. You can use Docker, Kube control if you're doing containerization, a bunch of other options. We'll look at a little bit more of those later. Ansible is written in Python and requires Python to run. The versions are a little different between the control and the host nodes. We'll talk about that in a few minutes. To actually configure this language, Ansible uses YAML. We'll talk a little bit more about YAML as well. It's similar to JSON, if you're familiar with JSON. It's also similar to Python, if you're familiar with Python. It's kind of a mix between those. For some of the fun variable stuff you can do with Ansible, it uses the Jinja templating language. So if you're familiar with like Handlemore's Mustache, Jinja's available like all sorts of different stuff. The other really nice thing about Ansible is that it's agentless. You install Ansible on your controller, but you don't need to have anything running for Ansible on any of the nodes that you're actually managing. It's just going in through one of these controllers, setting up states, and then no more running daemons, no more anything to do with Ansible. Ansible is only on your one node. YAML. YAML ain't markup language. And literally, again, it's not not quite JSON. It's actually a superset of JSON. The big things are it's human readable and also at the same time machine readable. There is a language available that will parse YAML in just about every high-level language you want to use: Java, Python, Ruby, any of the other like scripting languages you'd be familiar with. The big thing that's different between JSON and YAML is that YAML uses Pythonic indentation. So as you're moving through separating blocks of code, you have to use indent spacing. The other thing with YAML is that it uses actually a curl-like data structure. The actual things you're allowed to declare within YAML are strings, integers, lists, floats. We've got lists on there twice, apparently I can't copy and paste. Associative arrays, so you can have key value pairs similar to more traditional JSON. The other awesome thing about YAML is that comments begin with the octavord. Love the octavord. Unlike JSON, YAML is really easy to write comments in. So it's normal bash scripting you'd be used to, most languages really that you'd be used to writing comments. Same way you can do that in YAML. The other big thing with YAML, you can have multiple YAML documents within the same file. And what YAML does is say, anytime you have a line with 3 hyphens and nothing else, that's the start of the next document. And we'll see a little more about that here in a few minutes. So this is kind of an example of how YAML looks. You got your 3 hyphens here that start our document. You can have any kind of commenting stuff that you want up at the top. You're essentially creating lists when you're doing Ansible, and lists start with a hyphen and a space. That's also, again, really important. There's always a space between a hyphen and whatever you're declaring inside of the list. If you put them together, it complains about that in breaks. It uses colons for key and value pair separation. So you can even nest lists, as you see here. So you'll essentially have this list of tasks to start with, but then you can nest inside of that for tasks or other things. This is kind of an example of the Jinja templating. You'll use the 2 left braces, a variable name, and then 2 right braces to actually put a variable into a place. Jinja can actually do a whole lot fancier stuff. There's actually conditional logic, there's looping logic, there's a bunch of other stuff you can do within it. But that's the really basic. Take variable, put variable here. The other really cool thing, this is actually an Ansible thing specifically, importing and including. So if you start getting really massive configurations, you don't want to read 1,000 straight lines because you're just going to miss something. It's guaranteed you're going to miss something. So instead, you can create other YAML files and import or include them. The big difference between those, importing will parse at the beginning of the playbook. Include will apply exactly when it's run inside of the logic. It's a pre-parse versus like runtime parse of the information in that YAML file. So if you have variables changing that are dependent between the 2 of them, if you import it, variables that are set up front will be there. If you include it, if you change the variable, will be there after. The other really cool thing about Jinja is that it has filters, and there are a lot of filters. If you're familiar with piping things in Bash, exact same idea. What you're doing is you're taking the input, piping it to some sort of other command that will change it in some way. Some of those filters take parameters, some of them don't. A couple of really cool ones. Default allows you, this specifically are ones that are provided by the Jinja language itself. Default allows you to set a default variable. So if you pass a blank or null field to default, you can have it do, my variable is null, and whatever else you want it to output instead. If you have lists, you can use that to find either a min or a max value. So if you have a large list of numbers from port ranges, from anything else that you need to keep track of inside your playbooks, finding min and max ranges, you can do all sorts of other cool stuff with that. If you have a bunch of strings, if you want to make really nice, pretty everything, you can use upper, you can use lower, you can use capitalized. There's even a sentence case as well that you can use. I don't use that very often, but it's another option for string manipulation. Join is another really fun thing. You can put lists put lists together with a specific character separator. So if you have 15, 20 different ports or something you want to configure, and you have some command that will take them as a comma separated list, join, and then comma. Trim will clean up spacing for you, and the ever-popular URL encode, which will make things safe to be put on the web. Ansible, on top of Jinja, allows you to use a bunch of other filters. One of the ones I really like is toNiceJSON. There's actually a toJSON from Jinja itself, but that's difficult to read because it doesn't do pretty print spacing. And a lot of the times, if you're using one of these 2 things, you're actually wanting to look at it so you can actually debug what's going on. There's toNiceJSON that will make it much cleaner to read, be able to parse through the actual JSON objects themselves. Random is actually really cool too. You can have lists again, and if you just want a single one of those lists, you can use random to get a single value in the list. The power of that is you can use ranges. Jinja itself provides a random, but it only does that first thing I was talking about, where it'll pull one value out of it. With the Ansible part of it, you can do random between ranges. So if you're setting up, say, a cron job and you want it to run sometime within an hour, you can tell it to, you can pipe 60 to random, and it will choose one random number between 0 and 60 to actually put in the cron script. JSON query is incredibly powerful. If you've already got some structure inside of a JSON object, then you can use this JSON query to pull sets of that information out, similar to how we can do other kind of globbing language inside of Ansible. You can do that the same thing with this JSON query. So show me all of the elements that have some pattern-matched sub-element inside of it, inside of JSON. Really, really, really powerful. IP adder will check to see if your variable matches a standard IP address. Simple enough. So if you're trying to make sure that some random input gets properly formatted, IP adder will tell you yes or no. There's also a sub one of those that will do IPv4, another one that will do IPv6. If you want to do hashes in the middle of this, if you want to make sure something is exactly what you expect, the hash module will do that for you. You can pick pretty much any hash you can think of, MD5, SHA-1, SHA-2, SHA-512, SHA-56, all the different ones in between. The other really, really powerful one is password hash. A lot of times what we want to do is create user accounts, but we want to have specific hash values for their passwords. And specifically also if you're using the user module to create these users, it expects that to be a password hash. It doesn't want you to give it clear text because you don't want clear text in your playbooks. Password hash will take care of that for you. I'll actually show you a nice little demo of that here in just a few minutes. Inventory files. Ansible allows you to upfront tell it what you're trying to manage. You want to know what hosts that you're going to be working with, and it gives you a nice, clean way of providing all of these in a general single place. There's also, again, ways you can kind of combine them in other like import and include ways, but in general, inventory file. There are two options. You can either do the standard INI syntax, or it allows you to also do YAML, as Ansible would do. I personally like the INI. I think it's just cleaner to read, but again, if you're more of a YAML fan, sir.
Do you know if they've always done the YAML format, or is that
It's
something?
pretty new. I don't remember exactly which version, but it's pretty new.
Okay.
The other nice thing, you can also define certain variables inside of the inventory file. It's not specifically a best practice, but if you have, like, all of your web servers need to have a specific username to log into them, you can define that here. The other nice thing is if you have some really oddball host that has some completely weird kind of login thing, you can put it here instead of having to keep track of it somewhere else. It's an inventory, it gives you options. With the INI file specifically, that information goes at the end of the server name here. Also, these are server names, so they have to be resolvable. They don't necessarily have to be fully qualified. They don't necessarily have to be IP addresses or domain addresses, anything like that. But they have to be resolvable from the control machine. So you can either do that through local like SSH configs if you're doing SSH stuff. You can do that through DNS lookups. However you want, it has to be resolvable. With the YAML version of that for the different variables, it looks pretty much like the other YAML stuff. You would make children of this and say, this is my username, this is my password, this is the way I expect you to connect to this host. And again, it's kind of a weird nesting. All is how Ansible describes the entire set of hosts. So every one of the hosts that it knows about, if you want to run commands or run all, it does every host. With YAML, you have to be explicit with that, which is one reason I just don't like it. You're, again, with YAML Pythonic indentation, having to do a huge amount of extra spacing work, whatever. It is available as an option. Your control node. You have to at least have Python 2.7 or 3.5 plus. The OS needs to be one of the Unix flavors. You cannot use Windows as your control machine. For the connection, again, it defaults to SSH, but we have a whole lot of options we will explore in just a second. For each one of the nodes, you have to have Python installed again, but we have a little bit looser requirements. We only need Python 2.6 or Python 3.4. And it should be really quick. Okay. Ansible doc HT connection. This is the full list of everything that Ansible, your current version, will be able to use to connect. We have everything from Chroot stuff to Docker and Cube. If you want to do actually like even jail versus Chroot. Paramiko SSH is a Python-specific SSH server if you're just really out in some weird land where you can't get SSH. You can use Salt to piggyback off of those. You can use local, which is another really nice thing. If you're doing a lot of just testing and stuff for random odd commands, if you tell it the connection is local, instead of trying to go out and connect on SSH or connect over whatever else, it just runs the command on your local box. So really, really nice for testing. Persistent sockets, if you want to set up like sockets for managing things. WinRM again for talking over to Microsoft. There's also a PowerShell, PSRP if you want to do PowerShell remoting. Lots and lots of different options. Excuse me.
What's really cool about Windows recently is PowerShell is now something with SSH.
Nice.
Much more natively than it ever used to be, so that's made it a lot easier for me to manage Windows with Ansible.
Good. I've actually not tried. How I originally got into Ansible, I had a really old, like $300, like really crappy computer off of Amazon that I put Linux on, and I would abuse this thing, and it inevitably get in some weird state that I'd be like, you know what, forget it, I'm just going to wipe it and put stuff back onto it. So from there, I was like, I am really, really tired of typing install this, install this, install this, install this. Just mind-numbing. So I'm looking for essentially the exact solution that Ansible provides, which is automation, repeatable installs. So if it works the first time, it'll work every time after. Pretty nice. Okay. Release my presentation. There we go. Okay. So those are the ones I wanted to specifically call out, but there's a bunch more. And again, anytime you want to find out specifically, you can run Ansible doc-t connection, and that will list out the ones you currently have available to you for your version. Ad-hoc commands. The real power of Ansible is being able to create scripts and really the YAML files, the configuration language. But sometimes it's just nice to be able to run a bunch of stuff on a bunch of servers and not have to worry about it. So we will do a little bit of playing with this. Two of the ones I specifically want to call out again, setup and ping. Those are interesting to watch if you need to make sure that your Ansible node can talk, your Ansible control can talk to a node, you can Ansible ping it. And it's a little bit more intelligent than just a ping because it's actually logging in with whatever connector that you have set up for that host. So you'll not know just that it can reach that specific endpoint, you'll also know, and I can connect. And setup is actually a default module that always runs unless you tell it not to, and it gathers a massive quantity of information about the box itself. I'll show you a little bit about that. The really nice thing again about it gathering all that information is that it gives you access to those inside of variables. So you can immediately do conditional logic. You can run tasks when you're on, say, a Red Hat version versus an Ubuntu version. If you're on, low memory servers, you can produce memory options in some of your services. You can do all these different things based on the information available to you on the host itself. So we'll do this. You can also cheat and tell it that an inventory file. You can point to an inventory file if you want. Or, if you tell it a comma-separated list, it treats that as the inventory file. So if you want to run things against local, you can do this. And specifically, you have to tell it to run against all hosts in the inventory, which is its local host. And then we'll do -m setup. And this is going to dump out all the stuff about my box. Massive, massive amount of information. Memory information, IP addresses, hardware addresses, everything it's currently connected to. It'll tell you the Ansible architecture, which is, again, if you've got a mixed environment of 32 and 64-bit machines. Hey, install the 64-bit packages over here, 32-bit packages over there. Ansible date time. If you need to make any kind of quick timestamp stuff, you can grab it directly out of there. You don't have to call another part to pull that into a variable. So it's provided for you. Or if, again, you want any small parts of this, it's all available inside of this object. Default IPv4, so this will actually give you default routes as well, not just your total overall stuff you have. Let's see. It'll even list hard drives, it'll list you all sorts of things. Boring. Yeah, it'll tell you what kind of controller you have. Massive quantity of information. All right, here we go. The Ansible distribution. So instead of having to make decisions on 64 versus 32, if you want to make a decision again on a package manager kind of thing that you want to use. The other nice thing is that also is provided down below. But if you have other distribution-specific things you want to do for, say, a hardening, something with a stick versus Ubuntu versus Red Hat, something like that, easy to make a decision based on variable information you have directly available to you. It'll give you major and minor release information. It'll give you what DNS services you're currently using, which apparently I'm not, which is alright. Other interesting things. Yeah, just massive quantity of information. What current shell you're using. Hostname, here we go. You can even figure out, doing any kind of logic based on hostname. If you have hostname patterns, again, you can use filters to pull out chunks of the patterns. You can use all sorts of other information with that as well. Here we go. Memfree will actually tell you running statistics on the box. So if you're also, you can use kind of this as a cheating way of gathering box statistics for you if you just need a quick, dirty way of getting a huge list of all of these, debug it to the console. There we go. Ansible Package Manager will tell you exactly which one of the package managers that it uses. So again, you can make easy decisions. Do I use... Ansible has modules both for apt and actually most of the different package managers across the whole ecosystem, really. Apt, emerge, yum, deb, I think specifically there's one for that as well. And processor information, swap stuff, also important. Do you have a bunch of stuff that's currently sitting on your hard drive swap space? That's add time. Yeah, so that's the majority of Ansible's setup. That runs, again, by default for every single playbook that you run, and that information is available to you for each one of the hosts that you're currently working on. So it also gets changed every time, so host A will have that parsed out, host B. There's ways to bounce back around and find host A's information also, if you want to do comparison, clustering, and that. Let's see. Cheat and not use an inventory file this time. Because I forgot to tell it what user. By default, important point, if you run an Ansible Ad-hoc command, it will use the user you are currently logged in as. So I'm currently logged in on my local box user. My local box user is not on my Raspberry Pi. So you have to specifically use, tell it which account to use with -u. If it needs a specific password, I actually have a key set up for this one because I've been playing with it. But if you're not using a specific SSH key, you can ask Ansible to prompt you for a password. And it'll say, hey, I know you want this user, tell me the password. So that's the right password. And ping and pong. The other nice thing, you'll see a success message, and again, Ansible's kind of nice. You can see if it fails, bright red. Obviously, that's only on the console. If you put it into some sort of log file, it's not going to come out bright red in your log file, but of course, you can put filters on it. You'll get back ping and pong if you have a successful connection test between your services. Another nice thing, instead of doing specific, you can just do all. And yeah, that's, this is actually another good point. If you ask for a password, it has to be the same across each one of the services. Really, really important. This is the host file I'm using. So my local host I have set up to be here, so I can actually talk to myself, do some testing and stuff. But notice that I'm also telling it that the connection to use is the local connection, so you don't try to constantly SSH to yourself and hang connections up like that. And instead of figuring out how to resolve the specific host, my Pi1 specifically says, there we go. Instead of trying to figure out how to resolve this specific address that I have, I just went ahead and told it, this is the IP address of one, this is the IP address of the other. Use those. For each of those also, you can specify users, you can specify a bunch of other options. Check the documentation. The documentation for Ansible is absolutely fantastic. I should put this up really quick. This is the shell module. One of the things that's also kind of stupid, Google has like all of these indexed, so if you search for one of the modules, there's a really, really good chance you're going to get the highest result as one of the older versions. So every time that you get an older version, there's going to be this little piece right here that you're going to have to change to say latest. That's terrible to see because it's really, really tiny. Currently, the latest version is 2.7, but you'll see a lot of 2.4, 2.6 kind of just randomly scattered out through Google results. It specifically lists you every possible parameter, whether they are required. Any of the documentation later has this really nice feature where it'll tell you when it was added. So if you're working on something new and you have some box that has a much older Ansible version that you just have to work around, I can't use this particular command because this wasn't added in the version I've got. Really, really excellent documentation. It also has a lot of really good caveat information. Specifically, this is the shell module that I have up here. Let's see if I can make this a little bit bigger. That's better. Okay. So it'll tell you warnings like, hi, this is the shell. This gives you root access. Be careful with it. When you're using Ansible, by default, it becomes a root level user because, again, you're doing a lot of system-y, rooty type stuff that you have to have access and high-level permissions for. There's a bunch of different ways to declare how you want to do that. You can actually just SU to the root user. By default, the user you log in as needs to have sudo. But yeah, if you're using like the shell module, be careful because this is a raw shell. It will execute exactly what you tell it to as root. If you put rn/, it will execute that as root. Let's see. There's actually a safer version of this called command. But yeah, we're hackers here. We're going to use the unsafe version. It's fine. Command will do some like parameterization type stuff that will check for it. Basically, we'll at the end of the day run the same things, but with a little bit of type checking and safety. Okay. Really, really excellent documentation. That was the point of the thing. Okay. Other cool things that we can do. Presentation. Playbooks. So again, you can run these commands and that's all fine and dandy, but that's a command and you're in. And if you want to do it again, you have to physically type the command again. Nobody wants to keep doing that over and over and over again, especially if you're doing a bunch of stuff. So if you want to configure about 400 firewall rules every time, no, nobody wants to do that. That's ridiculous. You want to put it in a file, let it run itself. A couple of interesting things. For a Ansible Ad-hoc command, you use just Ansible. For a playbook, the command is Ansible-playbook. Specifically, the playbook requires you to pass it a YAML file, and it's the default single option that it needs. It has a bunch of other command line options you can use, ones that are frequent, and I'll show you a little more here in a minute. Like I said, the -K will ask you for the SSH password. The -U will ask you for which user you want to use for the play. Vault pass, which we'll come to in just a minute here. And the -K will ask you for the sudo password for the user you're logging as. There are a bunch of ways to put sudo passwords in, because everyone's using passwords on sudo, right? We want to make sure that stuff is secure, and we can either tell it up front when we're putting the thing in to prompt us for the password, or we can use the vault. The vault is a really cool feature in Ansible. It was added back in 2.4, I think. Maybe a little earlier than that. 2-point-something. And what Ansible Vault allows you to do is AES 256 encrypt values. And not just values, but entire files of values. And then Ansible knows as it's running how to decrypt back when you tell it what the password is, which is why we ask for the vault password. So, okay. Actually, I think it's my next slide. Good. Yeah, there we go. Vault. Ansible has a couple of different ways to start. If you're doing a single value that you want to encrypt, such as a password, and you want to put that inside of a bunch of other things that are not otherwise encrypted, here's our set of usernames, here's whatever else that we just don't care if anyone can see in clear text. Encrypt string is actually my preference for that. It'll encrypt a piece at a time, but you can still get a variable name. And also the really nice part about that is you can find where those variables are declared. If you encrypt the whole file, you got an encrypted blob, and you can't grep that. You can't grep encrypted blobs. Create and encrypt are essentially the same thing. Create will actually put the file there to start with. Encrypt will do one on the file that it is there to start with. Both will take a file, make it an AES encrypted blob. Let's play with Ansible Vault. So, specifically for the demo I'm going to do here in just a few minutes, what I needed was a way to set a new user password on the Pi. Everyone knows that there's Pi user, which just kind of gives it a terrible attack surface. Let's get rid of it entirely. But we need to have a second user, and we need to be able to set a password for this user, so then we can set up SSH keys and everything else. Well, we still have to put a password on there to start with. So, if we're going to create a password, remember what I said about password hash, we can do this directly through Ansible. Vault password. I made myself a script, because it's kind of what I do. You pass in specifically what variable name that you want Ansible to be able to see this encrypted password as. And if you don't give it to that, it'll prompt you, hey, I need that, it's important. It will check to ask you for what you want that password to actually be, and it'll keep doing that until you put in the same thing twice, just to make sure you actually get what you want on that box. This is a fun command I found on the internet and shamelessly stole. What we're going to do, let's down a bit. We're going to take 600 characters out of dev random. We're going to take only the characters that are A through Z, uppercase and lowercase, and numbers. And then we're going to take 20 of those per line, and then find the first 20 of them by head-1. What this provides us is a random salt that we can use for our passwords. So really what we're doing at the very end of the day here, we're going to have an AES encrypted blob that is a salted hashed value of the password that we actually want. Doing it this way, at no point of time is that password ever sitting on a file system anywhere. It's all in memory, all the time, the end. So, once we have this salt value, we're going to run a look at Ansible Ad-hoc command. Specifically on localhost, because we're not trying to bounce out some other server, we just want this thing to run locally. Using the debug module, we can print variables back to the screen. And I'm specifically printing the value of whatever that password is, assuming that they both match at this point, to this function called password hash. You can set, again, the actual hash type that you want, but since we're creating it, why not SHA-512? Let's go crazy. You don't have to pass it as salt. Highly recommend you pass your password hash as salt. And from this, we know that it's going to be random character values. We're really confident that there's actually random salt instead of predictable salt. Makes your password stronger. The rest of this, what this is doing, because it's an Ansible command, is printing back all that other fun, happy stuff of success and everything else. We don't want to look at all of that. Essentially, we want that value just to be in a variable so we can dump it back to the screen eventually. So we're pulling all this information out. We want to get rid of some quotes in there. We only want to print the actual parameter, not the responsive message from the debug. I can actually just run this because it's fun to look at. And so let's say our super password is password 1. That's what everybody's super password is, right? Super password. Our start value, we're going to do something stupid, but 1, 2, 3, 4, 5. Not very strong, but that's okay. So we run this, what we get back is, again, all the Ansible stuff that says, hey, I did the thing you asked me to do. Good job. Message, which is, again, the specific thing you told it to print out. And this big old monstrosity here is the actual password hash, as well as, looky there, our salt value. You say 1, 2, 3, 4, 5, don't do that. Very, very bad, don't do that in production. So, that script that I was running will just parse out the specific chunk of that we need, which is the big hashed value string. And then we're going to pass that directly to Ansible Vault to encrypt the string. The name is that thing we passed in or prompted for up here, which is whatever you want the name to be. And it takes that pass string. So, let's go ahead and just run this. It's cool. Vault password. But you guys want the password variable name to be. What sounds really secure?
Fall 2018.
Vault 2018. Ed, check this out. Our password is going to be so secure. Or if I get time. Like I said, it prompts you for the password twice. Now the important thing is it will also prompt you, once it hits the Ansible Vault, what password you actually want to use for the encryption. It's AES 256, so what we have is symmetric encryption. So we need a key to be able to lock and unlock it. And use strong passwords for this. Ours is going to be the strongest password. Yes, so you should confirm that. Type this correctly when you're using the script, because if you don't, then you have to start over, which is super annoying. And what it dumps out is this big old block of text. When you declare the variable in Ansible, again, what you're doing is colon delimiting, so we have, this is our name, colon. Normally, you would just put a string here or whatever else, but Ansible recognizes the special value of bang vault to be a AES encrypted blob incoming. And pipe is actually what it uses for telling it that stuff happens on the next line that should still be on the same block as what we're currently using. And this here is our big old encrypted block of text. So this is great. Yeah, we encrypted it, that looks cool. But it doesn't do a whole lot of good if we can't actually decrypt it right back, right? Yeah, thing for this. Test vault. Created a really, really dumb password vault tester here. Oops, I forgot that actually. So, what we're going to do is paste exactly what we just got off the command line there. Read out the old one that was playing with the test. And tell it that instead of debugging PyPass as the variable, we will debug Vault 2018. And we run the Ansible playbook of test Vault. Failed? How did that happen? Oh, we don't have a vault password. Because we didn't tell Ansible to ask us for it. Prompt. And we get back the old password hashing. And again, this is using the debug module, so we can actually see just stuff back on the screen. You wouldn't normally dump this back to screen. You would actually pass it to, say, the user module to actually create a user for you. And in fact, that's what we'll do here. I'll show you the actual script that does that. But that's an easy way to tell. Test also, make sure that you actually encrypted the thing you expected to encrypt with the right password you expected to encrypt with. Also, like I said, gathering facts. That is the setup module doing its job. I didn't tell it to do that. Oops. Test vault. Other important, I'll show you in a second. Started with 3 hyphens, gave it a name, told it we're only going to do this on the local host, debug is all we're going to do here. Notice nowhere in there that I say, hey, run setup. Setup just happens automatically. We can disable that, but we're not going to right now. So notice how up here the thing failed. When any Ansible playbook fails, you get this magic retry thing. Very, very nice. And this will keep some of the information for you to be able to restart your playbooks. A whole lot of useful thing for just a test file, but if you're in the middle of things, it will tell you where you were so you don't have to completely start over from the very beginning of a giant script across your entire enterprise. Okay. Test faults on a retry. Okay, cool. Next. So now we can create the vault password. Go back to presentation. SSH keys. So it's really, really terrible to have to try to type SSH keys in all the time, especially if you're using really long ones like you should be. You want to be able to run this automatically without having to constantly re-password or re-key in your password. Easy way to do that to start with is using SSH agent. Also important, depending again on like exactly what your configuration is, you probably should be using elliptic curve keys at this time. You can create this with others, but modern versions of Ansible and pretty much every modern SSH server will accept the elliptic curve SSH keys. Start using them, keep using them, make everybody more secure. You can use, by default, SSH copy ID to put them on the server, or you can do it with Ansible. Ansible's cool like that. To start with, when you create the key, add it to your agent, which I'll show you here. I have mine in there, so why don't you just you want to remove all the identities in your agent, dash capital D for SSH add, SSH ID, E25519. Cool. Ask you for a key. Type my key correctly. Nice hat you have there, sir. As your identity to the agent, and now we don't have to type that in for as long as we're still connected to our agent. Okay. Last but not least, maybe last, I guess. Resources. If you're really, really stuck, use very, very verbose. It will tell you a huge amount of information as Ansible is running. It will fill up your logs really, really fast if you're logging it, so be careful. Don't do it in production if you can avoid it. Super important. The Ansible documentation's freaking phenomenal. Cannot stress that enough. Anytime you're stuck, there's going to be a solution up on there. The source code for all the stuff that I'm doing today is not currently posted there, but it will be in the next couple of days. I have to clean it up a little bit from some stuff I was playing with, but everything will be up on my GitHub account. Okay. Now let's get into some fun, cool stuff here. All right, to start with, one last thing I need to show you that I didn't put in the presentation itself. Ansible has a default way of recognizing file patterns. Ansible is very much convention over configuration if you can avoid it. So when you're doing specifically roles, roles are a way of defining what type of service your host is going to provide. It's a way of also easily grouping tasks together. So if you're doing, like, say, some sort of security setup, then you can create a security role and apply that to whichever servers need some sort of security role. If you have some sort of, like, extra super secret double plus hardened role, apply that to just the services that need it, or servers that need it. Also, anytime I'm saying servers again, it's any of your Windows, your Docker, your Kubernetes, any of the ones you can connect to as your host, virtual machines, the whole gamut of things that Ansible allows. Okay, by default, a role, when you run a playbook, it looks for a folder called roles in the same directory as the playbook. And again, this way you're not having to constantly redefine where am I going to go look for role, where am I going to go look for this, where am I going to go look for that. It's all right there in the place that Ansible just knows how to get to. CD roles. Inside the roles, every single one of those will be a available role you can use in Ansible. So let's go to Pi setup. Inside of each one of the roles, there's another, again, convention set of folders. Defaults, files, handlers, meta, tasks, templates, and vars. Any of your agenda templates goes into templates. If you have any variables that are specific to this role, put it in the vars folder. Tasks is the really, really big important one. It's what actually defines the set of things that get run to make a server be this role. Handlers are more advanced than I'm going to cover today, but it allows you to tie back tasks to certain event, or to handle certain events. So if you're changing a bunch of services specifically, and at some point in time you're going to have to actually reboot the server, after you do all of these, instead of telling each one to reboot the server after each service you do, you simply tell it, hey, notify the handler that the server needs rebooted, and then at the end, it'll understand, oh, once we've finished everything, process that to make sure that it actually happens, but not in the middle of my playbook. A bunch of other stuff you can do with handlers, super important. Any kind of files that you want as default for the server itself, if you're transferring any kind of like web content up for some sort of like web server role, abandoned files, if you have any kind of configuration files for your application that need to be put in some specific place on the server, put it in files. If it's in files and you give it a name, or you tell Ansible to copy a file with a specific name, Ansible will specifically go look in the files directory to get it. You don't have to hard-code paths of relative to this playbook or that playbook, whatever. It's understood in the role itself. Files the way it's used. Convention over configuration. A nice script, actually, that I stole from my friend Holder here.
Not true.
It's half true. I'll claim it half true. I made some improvements.
That hurts. That right on video too. That's
Right on video.
right to the god right there.
I added GitOps. It's not a great improvement, but it gives you some command flags. It's polish. I'm not going to claim improvement, I'll claim polish. How about that? Will you accept polish?
I'll accept polish.
Alright. So specifically, you need to be able to create a role. For this script, it'll create a role in a target directory, optionally, or current directory if you don't give it that. Let's see. I got lazy with the script too. Instead of actually prompting the user for the role name, I'm expecting you to pass it in. If you don't, I'm just telling you, no, really put it in. It's important. And also one little safety check. So if the role name folder already exists, don't try to recreate it. Don't blow away everything you got there already. Bad times. Don't do that. So a big thing also, because we want this repeatable, auditability is important. So version control. So the script will create a few blank, well, not blank, but by default, mostly blank files inside of these directories. So when you just do a git add on the directory, it will actually pull the entire directory structure into git properly. And that way you're not having to say, oh, well, I forgot to add metas, I forgot to add whatever. You can obviously delete these later on, but this will set up the full gamut of Ansible recognized folders and everything structured for you here. For all the ones that specifically require different YAML files, it'll create you a real default YAML file of 3 hyphens. The other convention, which is really important to note with these, when you're calling into, say, tasks or handlers or anything else, Ansible will find a main.yaml file. It expects you to have that there so that it can figure out what else it needs to do for that. But again, because we have like include tasks and import tasks and other ways of changing things around, if you've got really, really complicated stuff, you can just, inside of your main.yaml, include the other files that you currently have beside it. And I'll show you a little bit of that here in a minute. Okay. For the files in templates directory, which don't have default files, blank readme files. Sure, why not? Again, this is literally meant to create directory structures inside of... so let's create -n class text. And it'll tell you, hey, I did the thing. If you look at class test, hey, look at that. And again, in true Ansible idempotent fashion, you tell it to do it again. I'm not going to do that. I already did it. It's there. No big deal. Okay. I set up. So, in PySetup, really the interesting thing I have in here is tasks. Actually, sorry. First, I'm going to go into vars. Vars is the other really, really interesting thing. Even in vars, you have a main.yaml, which is main.yaml. There we go. Nice. Fit, actually. Very nice. There we go. Main.yaml. Any, again, variables that you need inside of your specific role here go into main.yaml or, again, import, include, whatever from there. For this one, we're saying that the user that we're going to be using is Pi, which is the default Raspberry Pi user, and Ansible SSH pass. This is important. Again, this will be the exact password that Ansible tries to use to connect cross SSH into this user. That's plain text. Never, ever, ever, ever put your passwords in plain text in production. However, this is literally public information. Everybody knows to connect to Pi on Raspberry Pi, Raspberry. So I'm not encrypting that because it's literally public knowledge. And I'm setting these boxes up from absolute bare default. I cheated a little bit for the class because they actually are connected to networks that I had to go in and set up to make sure that worked. But didn't change passwords, didn't do any of the other like normal setup stuff because we're going to do that with Ansible. Okay. So my Pi pass is right here. So the other thing is, for interim, we still don't want to leave the password for the Pi user as Raspberry. That's a terrible plan. Very, very terrible plan. So what I did is actually created myself a password and stuck it into a vault. So now, when we do this initial configuration of the Raspberry Pi, it will first decrypt this AES-256 blob, and then it will set that as the user's password for the Pi user. And my actual user that I'm going to be using, I call it Tau, and I call it Tau in honor of my 2 Pi. And again, another big old password vault here for the encrypted side of hashed password plus really long salt that I want the Tau user to have to be able to log in. Okay, next. Again, pretty basic. 3 hyphens here in the var file. and then really, really short set of variables that we need for you. That also allows you, if you decide that you don't want tau to be your user, you can change it later, do whatever. Pretty nice stuff. Okay. Vars gets parsed before, which is another important point. Before the actual tasks get run, it imports all the var file stuff, so that way it's available for you. You're not trying to do that in the middle somewhere. It's pre-loaded information for you. Okay. Let's go to tasks. All right. Yeah, like I said, main, you can just include tasks. This is super boring, but I did prove a point. I only have exactly one other file, so every bit of the stuff that I'm putting in when I'm calling setup.yaml, I could easily just put directly into this file. But Ansible Playbook will say, oh, I need to go find that other stuff and put it in here. I could have used import or include interchangeably here, because literally nothing else is happening, so runtime versus any other time won't really matter. But include just because it's good. Okay, so let's check our setup file. Big thing we're going to do, make sure that the SSH and the sudo groups are present. We're going to actually add the user with the name from our vars file of tau. That'll be pi_user. And then for Ansible, most things work on states. You either want something there, you don't want something there. You want something to be in some other random state of up, down, restart, something like that. So when you're running these playbooks, you tell it what state you want it to be in, and then don't worry about it. For the user group again, append, we want to not clobber our groups that we're going to add here in just a second. We want to make sure that our new user is actually able to do SSH into the box, and also to sudo for root permissions later. Also important, make sure you put the shell in properly. If you just tell it bash, it will not work. You get connection errors all over the place because it's like, I don't know how to parse bash. And then you yell and scream like, why don't you know how to parse bash? You are bash. Bin bash, really, really important. And then again, we're setting this password, which at this point, we've already given it the password for the vault. It's already decrypted. It's already available for our playbook. It's simply just dump from memory directly to hash on the disk. Super nice. Okay, here. So we also want to make sure that we can log into our Pi user with a key. Eventually we're going to delete the Pi user, but for right now we'll leave it just to make sure we've actually got stuff testing, we can work with it, everything else. And again, normally when you go and you want files, you dump it into files. But you really just don't want to put a bunch of public keys up there because then you have to manage it inside of that. If you're going again on local home user network, you're not trying to manage a whole set of public key files, private key files off to the side. You just want to use it in your home directory. So what we're going to do is use this magic thing called lookup. There's actually a bunch of different things you can do with this. You can do it with web URLs, but files is the really cool part for what we're going to look at. Actually, we're going to use it twice. So we're going to look up, but first, a file. And we're telling the first lookup here to look for a file. But then we're using lookup again to find an environment variable called home. So now we don't have to worry about where that actually is inside of your home, your username or anything else. Using environment home, just give me that. And we're concatenating that with the actual key public key that we want to put onto the server inside of the authorized key. The authorized key module will do the same thing that SSH copy ID will do. In effect. The nice thing about the authorized key module is once you have any random user that will do that, all you have to do is tell it which user that you actually want that information in. So right now, currently, when we run this task, we have to be the Pi user because our actual work user doesn't exist on the box yet. So as the Pi user, as user Pi, I named my variables terribly, I apologize. As user Pi on the Pi, we're going to take the public key that we want to be able to use for both it and also for our new user and put those keys in there. And again, also, we want to make sure in our user that the Pi user has that password that we sent. State present, again, we're making sure things exist. Pi is going to exist because that's what we've been using as. In general, it's really good to be explicit for what state you want things to be in inside of your playbooks. That way, if for some reason, some version later decides to change it, you're not getting weird, unexpected behavior. You're telling it, this is what I want, do this. Don't rely on default for the state. Okay. Again, with Pi, I know I've got Raspbian on it, so I don't have to worry about figuring out which package manager to use. I'm just saying, go get apt and do an update. You can also do upgrades with that. So pull update cache, pull upgrade. And you can tell it exactly how long, if you run the playbook a bunch of times in a row, how long to wait before it actually goes and does an update again. So I don't want to keep running apt update every time I run this and testing. So set a reasonable cache valid time for how long you want to wait in between. Reasonable is entirely up to the user. A couple things that we need to install on the Pi. For one, Vim. I don't have any idea why Vim is not installed by default, but it's not, so we have to install it first. VI is, but not Vim. And we also want to install UFW, so we can actually do some nice security stuff on the Pi without getting completely out of it. So, other conventions that I use, anytime I'm doing anything related to security, when you run the playbook, it will dump out the name exactly as you have it on each one of the elements. So I can quickly go through and find security and know, oh, these security things happen. And the other really nice thing about that is you can quickly see, oh, did any of the security things fail or come back with some weird state of some sort. By default also, if something fails in Ansible, the playbook just stops. There's ways to, again, kind of handle that and recover and do other stuff with it, but by default, error means stop. That's also kind of a good reason for, there's another concept in Ansible called blocks, so you can essentially group all of a certain set of tasks that have to happen together. This is actually a really good case for a block, I just didn't put it in there specifically. The first thing I do here, if you look, is disable my firewall. It's technically not enabled at that point anyway, but if we do this for, again, future run-throughs of the playbook, I'm disabling my firewall. So, if you want things to happen and be able to recover, put it in a block, and then specifically say at the end of the block there's a finally command that will make sure that a specific thing happens if everything else goes bad. And for that, again, you want to, say, re-enable the firewall. Sounds good. Okay, we want to put in really basic firewall rules to start with. Deny everything incoming, then allow everything outgoing, real default. Specifically, we want to, for this, we don't actually do a state present for this. We're specifically telling it delete, or if you don't tell it delete, it just adds it in. I don't know why UFW breaks the convention that pretty much everything else uses, but specifically there are default SSH rules in there, and if you try to add other SSH rules on top of that, it gets real weird real fast. So what I want is this set of SSH rules, specifically the rule of limit, which what that does is, as the comment above says, limits the connection rate, so you can get 6 failures for 30 seconds, and then it just stops letting you try that. So, real nice, convenient way of keeping yourself protected a little bit from some spam attacks. Okay, and also specifically for that log, so when, I forget the exact number of failures happens, they'll start logging each successive attempt. I think you get 1 or 2 for free, but then it starts logging after that. So, and then again, the last thing we're going to do is re-enable firewall to report. Again, would have been nice in a block, I just completely forgot to do that. Okay, so that's what the task will do for what the whole role of Pi setup will do for us. Get us a user that we can actually work with, make sure that the Pi user doesn't have a password of Raspberry, get keys set up, enable a firewall, really basic firewall that specifically allows us SSH. Also, if you enable a firewall and you deny all the incoming before you enable SSH and you enable a firewall, you get locked out of your client, you have to reflash it. That's important. Don't do that. It's all. Okay. Let's see. So let's go back up here. Okay. And so what I have up here is a playbook that I'm calling py.yaml. Doing a little bit of stuff here, and we're actually going to cheat a little bit. So the first thing that my playbook does, oh look, we have other playbooks we can use. It imports this other playbook called distribute key. And what the distribute key does for us is make sure that the Raspberry Pi user Pi has that key present. It's super important for that, because if you don't, then you end up getting locked out in weird places. So doing that up front, taking care of it, not worrying about it anymore. And again, every single time we will check to make sure that that public key is in that place that it expects it to be. So every successive run is super easy. Okay. Next. That's hard. Okay. So what it will do is say for a specific set of hosts, and for this one I'm just using the Pi1 because it was the easy one that was actually mostly set up already. What user that we're going to be using to connect, which is the Pi. Become is telling it that we definitely need permissions because we're going to be doing a bunch of sudo level access stuff. And then it says what roles do we need to apply to this specific host. Again, if you're into the inventory file, we have things that are like all the pies, just are group pies. So if I wanted to just create group pi and tell it host pi, then that. This is individually set up for Pi1, Pi1 and Pi2. For quick demo purposes, we're just going to do it on one box because it'll take forever if we try to do this over local network stuff. So, anyway, this is the part that is not cleanly working here. This has been around for about a little over an hour and a half now, and it's still not done. So we're not going to do that as part of the live demo. I was hoping to have it pre-done again because it's idempotent. We wouldn't have to redo it a bunch of times. So we're cheating when we're doing it this next time and rerunning this playbook. There's a magic condition called when that allows you to define a variable condition for when a task actually gets done, or if it actually gets done, really. So when false, never runs. It says, okay, you don't need to do the thing, then I can't. Okay, whatever. Specifically, again, normally when we would do this, we would go back and use our new created user here, but we can't, so I'm just basically turning this off for the demo. I'll fix it eventually, put it up on GitHub, but it's some weird networking thing here. Worked at home, don't know why it's not working here. Okay. Let's go ahead and just kill this, because it's not. Once if you kill it, if you look, it's Python. That's all it's doing. It's running some Python stuff. In fact, even literally what it does is copy over some Python module stuff to the server and then run the Python module stuff, then take it off. So that's what it does. Python. Okay. So, I didn't cheat. You clearly see what I was about to do there. If I just tell it that, oops. That's apparently I'm bad. Live demos again. Okay, so apparently you can't use when on plays, so instead what we're going to do is just comment it out. Remember how that commenting is easy? That'll teach it. When does work on tasks, apparently doesn't work on playbooks. Now I know. Okay. Let's try this again. So cool. We're going to run this playbook. We're going to send the key first. That was getting that first set of tasks. Every time. Tell it to ask me for the vault password. Also, it's ask vault pass, not ask vault password. If you type ask vault password, it just complains that it doesn't know what you're asking for and it doesn't work. You get angry and yell at it again. It's a whole cycle. Other important point. In general, up until I believe I think the very latest version just finally changed it. If you prompt for the vault password, it's the same vault password across. There's some new configuration options, which I believe are called like Vault ID, which I haven't had enough time to look into to be able to reasonably tell you guys about that. You can specify individual vault IDs, so if you have like a dev vault versus a prod vault versus whatever, you can have different passwords for that, which again, 2 thumbs up, keep your dev and prod stuff separate. For what I'm showing you, if you just prompt for a vault password, it has to be the same password across the board for any variables that you're using. Type that. We'll find out. We'll find out. Yeah. Work that time. Okay. Again, as you can see, each one of these that I'm doing, because I've already done it, it says, okay, I don't have to redo this, so it's being able to skip through it really, really, really fast. The apt module takes it a minute because it still has to figure out how long ago it tried to do this last and still waits for forever. Just spin there for a minute. Oh, that's okay. Any questions? We'll start with that. Questions, comments, things thrown at me. Preferably not that last one.
I have a question.
Please.
Okay, so when you're running a playbook and you get to a step like update apt or something else, is there a way that you can see the state of the actual machine in case it's actually frozen or there's some kind of error that you don't know about?
That is a good question I do not know the answer to. I can find out. I will find out. Sir?
You mentioned how Vim wasn't installed on the Pi.
Yes.
Can you alias Vi to Vim and make it work without installing Vim?
Yeah, absolutely. Anything of the like Bash RC stuff, if you want to just do it that way, or Bash alias, whichever you prefer. Easily you can do that. There's actually a really nice module. Either if you want to have like a full-out configuration file pre-generated, stick it in roll or stick it in the files section in the roles, and just copy it over to that user, and it just magically works. There's also line in file, which is a module for Ansible that you can specifically change certain lines as a default. If you like the whole default one, but you just want that one line change, do a regular expression match and say, no, I actually want that line to say this instead. You don't get all the nice... This is the stuff where I'm having some network issues, which is why probably that other one failed. Yeah, very likely some network issues. Live demos every time. But we can just quickly go in and troubleshoot that. It keeps being route problems, which I don't quite understand why. It keeps forgetting my default route. Yeah, it just keeps forgetting. Defaults. Helps if I do that with root permission. Okay, let's try that again. Okay. Also, my super secret vault password is Fallout76 because about that time.
So with Ansible being on a system, you're a normal user, you see that it has the config files on it. Can you escalate your privilege to root through Ansible? Because I know on certain
If you have the right password or the right key file, yes.
Okay. So there's no way of kind of getting around that through Ansible?
None that I know of.
Okay.
There may be some security vulnerability, I just don't know. By default, you have to know either a password for a user with sudo, have sudo yourself, or have a key loaded into the agent, or again, know the password for one of the keys on the file system, to be able to assume that user on some remote machine.
Gotcha. Okay.
Which again, it's a really good setup. Like that way, we're not just constantly escalating privileges willy-nilly. Yeah, it worked way faster that time. Way faster. Okay. So yeah, I said, hey, I tried to update app. Now I actually understand how to do that. Cool. And so utilities, like I said, I just like to have Vim and UFW on there. And again, make that list as long as you want, anything that you really want on your pile at a time. There's actually a couple of really nice GitHub repos that have some really, really full tutorials for a bunch of the really common things on Pi. If you want to make yourself retro Pi or anything like that. There are playbooks available that will just do that for you, which is super nice. Notice again, we've gone through here, and all this stuff says, okay. I will also tell you specifically, oh look, we included this, so it's not really a okay or not, but we did this thing, it's important. It'll tell you exactly what hosts, specifically, that it's going down through and doing that on. So when we disable the firewall, it has a state that has changed, again, because I had this existing already. The firewall was enabled. So it says, okay, that's enabled, and that's now disabled, so state change. So you can see visibly when you're doing things. There's also ways you can essentially catch that and say, yeah, I don't really care to show it changed. I'm not recommending that for like the middle of a firewall change, but if you're doing echoing something or something like that, you don't really want to see it change. It doesn't really report anything useful to you. So yeah, green because we've already enabled the firewall policy of denying incoming traffic. We're already allowing outgoing traffic. None of this stuff has changed. Enabling the firewall again. The really cool thing at the end is play recap. We can see exactly what has changed, how many have changed, how many are okay. If any of our hosts are unreachable, it'll show us that. Anything that has failed. And that's a really easy way at the end to just quickly parse what has gone right or wrong. And I'm going to do something super dangerous and flip boxes, which is why I do Raspberry Pis over here. I'm trying to do the demo on the one, so I would have that backup to actually show. So go to our pi.yaml, and instead of just putting this on a Pi 1, let's tell it to host pies. It's all the pies, which may or may not work because again, we're networking issues. Pi 1. Oh, this is another important thing. My play for the Pi setup role, I specifically unhard-coded that in the distribute keys. It is only doing it on Pi 1. This actually might fail. It's not a possibility. We'll find out. Okay, so actually this is another interesting, cool thing to look at. Because Pi 2 has never had this set up on it, we can quickly see, oh look, we added a user, and now it's changed. Copying SSH key to that. Oh look, it's good for the first one we just did, and the second one has changed.
So let's say it fails right now. It gets out of Ansible Playbook. All the changes it did before doesn't revert going back to the default. So it actually just changed.
Everything there is set.
Okay.
Everything up to that point is set. And it's again one of the nice things about the idempotence, and that retry file is what hosts were broken. So you can go back and read your own playbook, which is fine because it has the ability to just know not to redo the stuff that's already done. It'll try, but then it says, okay, it's the state that I already want it to be in, so, hey, we're good. There's a bunch of also really fancy things you can do if you're not working on just like 2 hosts. Again, the document has a bunch of really good tutorials across all sorts of really broad level configuration stuff. You can group hosts by like region. Create a region group. Here's my southeast region. Here's my north region. Here's my whatever region. You can even create groups of groups. So here's my southeast web servers. Here's my northeast databases. Whatever. There's combinations of that. So you can have here's my just web servers, and then obviously. But the important thing is, notice that it fails on Pi 2, but keeps going. There's actually a new thing here. Pi 2 is done, but it's going to continue working on the one that you originally had set to go on. And we're going to fix this networking thing while that's running. It's not really useful. Look at that again. set that password to be. Ooh, buddy. This is also the problem with running demos and then just using keys all the time because you forget what you made the key.
Vault 76 or something.
It was the one I created previously. It was already hard-coded into there. There we go, we're good. Tau user did exactly what I told it to and copied the key in there for me. Thanks, Tau. Alright. There we go. I remember the Tau password. Okay. Yeah, I don't have that. Right. Every time. Yep. So I've got a switch sitting over here where my Pis are hardwired into it because I didn't trust Wi-Fi to try to bounce between. But every once in a while, it just decides that it should try to go out over the switch, which doesn't have an Ethernet, or doesn't have any like Ethernet to the wall. It's just a switch. So route del default. In. You notice it'll delete the first route, but not the second default. There's two defaults. It gets in just weird states for some reason. Just every once in a while, it'll get random. It's annoying. Okay. Let's check over here. Yeah, good. We can see clearly Pi 1 changed with those two that we had seen before. Pi 2, we got part of the way through. Good for us. Oh, look at that. It failed. All right. We'll go back to this. So then, it actually really tells us right here, to retry. So, Ansible, Playbook, YAML. Remember to ask me for my vol path. Actually, we're going to, other important thing that I forgot to show you. Ansible has a bunch of other configuration options you can do as like actual Ansible type level configurations instead of just individual like roles and stuff. There's a file called Ansible CFG. By default, again, Ansible has convention over configuration, and there are places that it expects things to be, which I believe is /etc/Ansible. But if you want to run stuff in a local repo or local folder, create an Ansible.cfg. It works kind of similar to like CSS, where the permissions, the longer, more specific ones, are ones that actually apply. So if you look at the configuration like on the command line, that is the one that takes precedence, which is why we can do the -i localhost comma. So this is my inventory file and my entire inventory file, so say we all. By default, I've been using the local copy of the inventory file that I have sitting beside this, because again, it's local pathed here. I hate having to constantly tell this thing to ask me for my vault password. So by default, we can just say, prompt me for that. And now we don't have to keep asking this. However, that will literally ask you every single time you do that. So if you're in the middle of testing some stuff, which is why that was comments about. Oops, also -- limit. Ansible class pi.retry. Give it the vault password. Back up and running. Pi 1, no host match, because we told it not to use that. So,
is there a way for you to tell it, when I have this error, run this fix?
The handlers will do that. You can basically try catch inside of Playbooks. What am I doing now? Why is that unreachable? We literally just fixed that. Let's take a look-see. What? We can definitely reach that. Oh. So why, this is a fun point too, why we can't reach that is because my playbook said to log in with the Pi user with password raspberry. What was one of the very first things we just did? Change the Pi password. So now when I'm trying to log back in as Pi, it's not working. So I kind of broke idempotence as a point of reference here. Bad time, should have done that. But here we are, so we're going to fix it. again, because my command line is my authoritative source, even though the role says connect with pi, I say connect with tau, and it still didn't work. Alright, well, showed me up, making a liar out of me. Let's check for the role really quick. I didn't think the role overwrote my command, but it may have. It may have. And it also may be more specific, which might be my other problem. Setup. Issue tasks. And then setup. Yeah, how about don't? Whoops, that's in bars, which is exactly why I did that. Because it parsed the bars after it checked my command line arguments and overwrote it. Huh. Today I've learned. Trying to teach you guys something, that taught me something. So let's just go ahead and clean that all out. And we're going to reset this to a slightly better state by manually doing this. Keys to /home/pi/.sh authorized keys. Now we're better. Okay. So another important point with that too. Notice that worked on the first one, even afterwards, but not the second pi, because the first pi had the key. So it defaults to trying SSH keys first, and if that fails and prompts for the password, then it uses that password you've already set, which is again why this has worked after I've run the playbook a time or two. And also why now my distribute keys, even if I changed it to pi2, would not have worked because the password's no longer Raspberry. Alright. Okay, where was I at? How about this? Can I overwrite that? That's my big stance. Default password. What? Just when you thought you couldn't screw up a live demo anymore. It's still prompting for a password. Why is it prompting me for a password? So I copied the authorized key file over. Pretty sure I did that, right? Everybody saw me do that? 50. Let's just count. That's going to be password. /home/pi/ch. Well, just super annoying. Oh, because root owns it. Hey, you can't use the authorized key file if it's owned by root. Some people's kids, mostly me. Okay, rewrite by the user, nobody else. Now it'll work. Famous last words. Here we go. And we're back in business. But yeah, really easy to recover also from Ansible stuff, because again, everything's just SSH. As long as you don't lock your stuff out really, really super hard, which I've done a couple of times, but that's also, again, why the error handling for that is really nice and useful. You can recover from that stuff like, hey, I was trying to copy this key over and it failed. Okay, handle that by undoing that password change thing. Like, go back and set it to some default thing that allows me back into the machine so I don't have to go re-image it. It's important. It's as much error handling as you want it to be. So this one is obviously 0. but you can do really, really safe playbooks, and especially again because we have the idempotence that is setting states instead of it trying to figure out like how to just keep reinstalling without clobbering things. Okay, so yeah, back in business. We'd already updated that, but now, notice this is actually different too. We installed the utilities this time, and it's changed. But the first thing we did here is disable the firewall, which didn't change the state, because the firewall was already disabled. We installed it, but never actually done anything with it. Apparently, the default comes with a deny incoming and allow outgoing, so good for it. Nice. The SSH rules, this is actually something I pulled over for some other stuff I was playing with, so apparently the Pi doesn't actually have those SSH rules. And it specifically will allow the SSH connections in and enable my firewall again. So just for good measure, let's actually, we're not going to use SSH, we're going to use Ansible. I guess we can. Pi 2. Oops. I don't need to do that. Hold on, we can. We don't have to give it a false inventory file because we're actually just using our own inventory file. That's good. So Ansible Pi 2 -m ping with my vault password, because I told us to prompt me for the vault password every single time. Uh-oh. I broke it. Oh, you know why? And anyone tell me why this didn't work? So you know I was paying attention when I did this earlier. Anybody? Give you hints. Who am I?
Tell it to use.
It looks up any password because there's nothing actually decrypting, so you just mash on the keys. I'm internet hacking. So yeah, I can connect both with my Pi user and my Tau user now that I have keys set up. And notice I didn't have to put in extra passwords, anything else, just that. So I'll show you the next part of this, and it didn't work, so I can't show you a cool like local live demo thing, but I'll actually explain a little bit more about it. The original intent with this whole thing, last year there was a really good keynote that specifically mentioned that if you're not monitoring, you're basically not building security. You need to know what's coming and going, you need to figure out what's normal, what's not normal, and then figure out how to manage that information. And one of the easy ways that I did that at home was Pi-hole. And what that is just a really fancy DNS server that blocks a bunch of ad domains. But because it is now my primary DNS, I can see all the traffic that keeps getting asked for over my network. The really important thing with that is it's not really intrusive. All you have to do is change the DNS server on your router to a static one instead of the one provided by your ISP, which is a really, really low bar for actually like really, really good network monitoring overall. Understand also that it's not perfect. You're not getting all traffic with that, but you're getting the majority of user traffic. It's not going to show you generally the malware, but it's going to show you just about everything else. You need more stuff for that, but really, really good first step. So over here, and we want to go to the hide. So this was what it's going to do. So it was originally going to run on all the Pis to start with to create the general setup, make sure the keys are there, the users are there, everything I want to be there. And then it was actually going to configure Pi-hole on one of the servers. You can use the other server for anything else that you want, but this way, just again, so we can show the nice differences between the changes and everything else. Okay, so had this have worked, again, we're executing a role. So we go into the roles directory, and the role is called Pi-hole. And inside of Pi-hole, we have, again, the nice create role script right there that has all the stuff on it. We do tasks. I don't think there's actually any bars for this. Nope. Literally the only thing in that is the 3 dashes because we created with the script. So inside of tasks, we have, let's quickly look. with this. Yeah, just main.yaml. Really cool thing about Pi-hole is that it's a super easy install. Single command, curl to bash. So this is also dangerous. Like I said earlier, bash right here, the shell module, you're literally piping whatever things from the internet directly to a root level terminal. That's dangerous. The really, really safe way to do this, if you weren't trying to do it on live demo or just kind of work locally, would be to actually download the script and have it sitting in the files directory and tell it, hey, put the files directory named Pi-hole on the server and run from there. That way you have it verified, you can check the actual correct signature and stuff. Actually, Holden had a, did you actually show that earlier in your class?
For what's that?
The curling to GPG for pipings to bash.
Yeah. So if you look at Zero Tier's site, they have their downloads, and it has a really good example.
So similar to that, instead of having to just curl the direct thing, you pipe it to GPG to actually make sure that it's doing what you're expecting it to, and you get the right signatures by the right keys by everything before you start piping things to root level bash. Yeah. The other thing is, because it's a DNS server, we have to punch a hole in the firewall. It says, hey, it's DNS traffic, instead of just dropping it off the floor. Okay. So that doesn't work. I can't really show you a cool look one because it's broken, and here we are. But this is essentially what you get with Pi-hole. It has this really, really nice dashboard, and this is actually their live demo on their website. So you can see, normally when you first come in, you're just seeing really high-level stuff, but log in. And there's no passwords, you just log in with the password. But a password on yours, it's important. So you can actually see numbers of requests coming in and out. You can see which clients specifically. You can alias them, you can do all kinds of cool stuff with that. What kinds of DNS queries are being done. A bunch of really, really nice information. And again, you can kind of see, oh, look, that spikes at midnight. What's somebody doing at midnight? What kind of thing do I have on my network? Looking at traffic somewhere. Monitoring. That's super important. Pretty good on that. Any other questions? I'm basically done, because I don't have other cool live demo stuff to show you.
If I wanted to do 2 Pi-holes,
Sure.
is there a way, if I wanted to add extra lists to Pi-holes, is there a way to have Ansible copy the list so that I don't have to go and add the list on one post and then go into this on the other post and add all those, so I can just...
That's a really good idea, but I'm not trying. There's got to be a way, because again, this is all sitting on a file somewhere on the box.
Right.
So essentially, inside of your playbook, you can create the whitelist file. And instead of just specifically clobbering it, if you have a bunch of ones you want to add to the existing, you can append that in the file instead of just clobbering it, which is pretty cool too. But again, you can do whitelists, blacklists, either one.
It's I have multiple blacklists added, just...
Yes.
That don't come with the out of the box, but I have 2 Pi-holes in my house.
How do you configure that with? Are you routing to both of them like an A and B side, or do you have specific network traffic splits?
So on my router, I have spots for 2 DNS.
Yeah.
And so I just have them both there.
There you go.
That way, if one of them comes unplugged or whatever, the other one still goes, and my wife doesn't say, "Hey, how come the internet?"
Why doesn't the internet work?
Yeah.
Yes, that's a great idea. And we all have 2 or 3 Pi sitting around, so might as well.
Well, I
Ansible.
had 2 Pi Zero Ws, and I got off of Newegg. I got a $20 battery backup with the USB plugs on it. So
yeah, that's fantastic. So yeah, my goal is to either show you something cool or entertain you with blinky lights. So if told me something, tell you something new. Questions, comments, thoughts, things to throw me again. All right, thanks for coming, guys. Appreciate it.